Question 10 of the January 2022 CSEC Mathematics past paper. Here, part A says 3 points O, P, and R are shown on the grid below. O is the origin. Write the position vector of R, OR in the form A, B. Alright, I already copied the parts of the question over here. So, part 1. Write the position vector of R in the form AB. I want you to pause the video and write that. Okay, you've done it. Let's look at it. OR. Remember, OR means you're going from O to R. Alright? Now, remember that column vector AB is in the form X, Y. X means how far do you go horizontally. If you go to the right, it's a positive. If you go to the left, it's a negative. Y is saying how far do you go vertically. If you go up, you move in a positive direction. If you go down, you move in a negative direction. Alright. Now the fact is you can go from O straight to R on this line. Or the alternate route is to go from O to here, then from here to R. That is your horizontal and vertical components. Now, A is going to be the horizontal movement. The horizontal movement is this movement. Remember, you could also go up and then across to R now. But here, we're going across and then up to R. Here now, how far do you move horizontally and in which direction? You move 1, 2, 3, 4, 5 units. And it is to the right. So A is going to be 5. Positive 5. Alright? Now, vertically, after you reach here, you turn the corner. You move up 1 unit. So B would be a positive 1. So the position vector is 5, 1. So there you have it. Now, just erase this. The next part says, another point Q is located in such a way that QR is 2, negative 4. Using this information, plot the point Q on the graph. Okay, so pause the video and go ahead with that. Alright, what did you do? And if you had printed the past paper, you would have had the graph to deal with. If you didn't, you could just quickly use a graph paper or line it up on plain paper and do it. Now here, remember, it says Q to R. Suppose Q was here, for argument's sake. Q to R would be horizontal movement and then vertical movement. Alright? But here, we don't know where Q is. So let's not try to go from Q to R, because we don't know where Q is, so we don't know our starting point. However, suppose we move from R to Q and we find RQ. RQ would be the inverse vector of QR. Alright? So in that case, it would be the inverse vector of 2, negative 4, which is negative 2, 4. So RQ is negative 2, 4. So that means in going from R to Q, we move horizontally 2 units to the left because it's negative. So we end up over 3, and then we move positive 4, which means 4 up. 1, 2, 3, 4. We would end up at 3, 5. So you see that it will be from R, negative 2, that's 2 units to the left, positive 4, 1, 2, 3, 4, 4 units up, and we'll end up here. So it means that Q would be here, alright? So Q is there. So here what they say, what did they say again? Using the information, plot point Q on the graph. Alright, so Q would be there. So remember, what we did earlier, you would show those things as part of your working. Alright? In order to get, you would show how you get Q. You won't just plot Q and not show the rough work. You have to show the rough work. Well, not really rough work, the working. Really the working. Now, you plotted Q. Determine QR with the vertical lines, as you see, the magnitude of vector QR. So, pause the video and show the magnitude of vector QR. Alright, you paused and you did that. Let's see how that works out. The magnitude of QR. QR would be this vector. Alright? Now, let us form a right angled triangle where QR would be the hypotenuse. This is the right angle here. Alright? Now, what you would have here is the two sides. This side is 2 units long. And this side is how many? 1, 2, 3, 4. 4 units long. You see that? So, the magnitude of QR, you use Pythagoras theorem to do it. So QR, the magnitude of QR squared equals 4 squared plus 2 squared, which is 16 plus 4, which is 20. So the magnitude of QR would be the square root of 20. Alright? And you calculate the square root of 20. So the square root of 20, it would be. That would be the magnitude of QR. What would it be now? When you work it out, what would you get for it? So the square root of 20 is 4.47. Alright? So equal 4.47. Now, after that, show by calculation that OPQR is a parallelogram. OPQR. Alright. Let's erase some of the working here. Let's keep QR and so on as it is. OPQR is a parallelogram. Now remember, you want to join OP together. So OPQR, and then you close the parallelogram. And you want to show that it is a parallelogram. So, how about you pause the video and do that? Alright, you did. Now, remember, for it to be a parallelogram, OP must be parallel to QR. Or say PO, it must be parallel to QR. And PQ must be parallel to QR. Right? That would show that is a parallelogram. So in that case, once these are parallel to each other, I use two arrowheads here now, show these different from the one arrowhead, and these are parallel. So how do you show that? Now PO, what is the vector PO? From P to O, what you want to show is that to go from P to O, you move 2 to the right and 1, 2, 3, 4 down. So PO is going to be positive 2, and 4 downwards mean negative 4. That's PO. What about QR? What is QR equal to? QR then is going to be, to go from Q to R, you move horizontally 2 to the right, vertically 1, 2, 3, 4 down. So it's 2, 4. Downwards means negative 4. Therefore, PO is parallel to QR. Show that. What about PQ now? PQ, what is the vector PQ? Right? PQ, horizontally you would move 1, 2, 3, 4, 5 to the right and 1 unit up. So PQ is 5 horizontally and 1 upward vertically. What about OR? The vector OR, what is it? Now for OR, you'd have to move 1 to go from O to R. You move 1, 2, 3, 4, 5 horizontally to the right. That's a positive 5, and vertically 1 upwards 1. So therefore PQ is parallel to, so it would be parallel to OR. That would be sufficient, to show that it is a parallelogram. Right? If you calculate the magnitudes, you would see that the magnitude of PO and the magnitude of QR would be the same. Right? Because what happened? PO, the magnitude of PO, will be the square root of 2 squared plus negative 4 squared. and the magnitude of QR from the information up here, it would be the same 2 squared plus negative 4 squared. You would need to work it out fully just to show that they are the same. That's the magnitude. And you can see that the magnitude of PQ would be square root of 5 squared plus 1 squared. That's the magnitude of PQ. For OR, it would be the same, square root of 5 squared plus 1 squared. Right? They have the same direction. The directions would be sufficient to show that it's a parallelogram. The directions alone. Alright? But you could also show the magnitudes also if you have enough time. So therefore, since PO is parallel to OR, to QR, and PQ is parallel to OR, so therefore OPQR is a parallelogram, a parallelogram, and you have shown that is shown. All right, let's look back at the paper. Where did we reach? That is a parallelogram. Okay, and then we have part B of the question. Let's leave part B for another video.